Good afternoon, everyone, and welcome to today's lecture. This is lecture number 2, and we are dealing with Newton's laws of motion. And in the last class, I think we were dealing with pulleys. Oh, sorry, we are dealing with free body diagrams, and we had seen what a free body diagram is all about. Yes or no? We had seen a free body diagram is nothing but a diagram where all the forces are drawn. And we had seen one force which is known as the reaction force, and we had seen one force which is known as the normal reaction force. Yes or no? Do we agree that we have seen this? Yes or no? Do we understand this? Are we there, beta? We understand about this normal force. This normal force is normal to the two bodies. Now let us move on to the next type of force that we'll also encounter, and that force is known as tension in the string. Tension in the string. Tension in the string. Now, what do you mean by tension in the string? It is also a type of electromagnetic force. And when you hang something by a string, let us say this block of mass m, we hang this block by a string, the string becomes tight. Yes or no? There is a force that comes in the string. The string becomes tight. That force that comes in the string when the string is tight is known as tension in the string. Do we understand this? That is the force. So that this is the force in the string. This is the force in the string when the string is tight. Tight or taut. If the string becomes loose, or the string breaks, tension becomes zero. Do we understand this? Do we understand this? Tension in a string can only pull. When you talk about tension, you cannot push something by a string. You can only pull something by a string. So if I draw the tension on this block is attached to the string. This is the tension on the block. Do you understand this? This block is pulled up by the string. It cannot be pushed down by the string. You understand this? Tension can only pull. It cannot push. These are some of the important points that we must remember. Strings are taken as massless. Strings are taken as massless, and therefore the tension T remains same. It's same everywhere in the string. Okay, can you remember this small points? These are very simple small points that we might encounter. If the string has mass, then tension would be different. at different points. And we will see one or two questions where we will have string with a mass. So these are the important things that you must remember about strings and tension in a string. Now, if you have two bodies which are attached to a string, two bodies attached to a string have same magnitude, and the most important term here is magnitude, have same magnitude of displacement, same magnitude of velocity, and same magnitude of acceleration. That is magnitude of V, magnitude of A, and magnitude of displacement is same. What do I mean by this? If I just I hope everyone is writing this. If I just draw a diagram, a very simple diagram, these are two bodies, M1 and M2, and this is a string between them, attached by a string. If I say that this body M2 moves a distance x forward, how much will the body B move? Body M1 move? The body M1 will also move the same distance x, yes or no? They cannot move differently because they are attached to the same string. If this moves with a velocity v, this will also move with a velocity v. Do we understand this? Yes or no? If this moves with an acceleration a, this will also move with an acceleration a in the same direction. Do we understand this? Yes or no?
Yes, sir.
Okay. Now, if I take a different case though, if I take the case like this, then you must understand. Here they are moving in the same direction with the same velocities. But here if I say that this moves down with an displacement x, body 1 cannot move down, but it will move ahead with the same magnitude x. Do we understand this? It cannot move downwards. If this moves downwards with a velocity v, this will move right with a velocity v. If this moves downward with an acceleration a, this will move rightwards with an acceleration a. And therefore, I have used the term magnitude of velocity, magnitude of acceleration, and magnitude of displacement, because their directions can be different. Do we understand this? So these are some of the things that you must remember about a string. I'll give you 2 minutes to note them down. Once you're done, please let me know. If you have any doubts, you can ask them anytime.
Completed, sir.
Everyone done?
Yes, sir.
Boys, girls? Shall we move ahead? Okay. Now remember, beta, for you NEET students, remember the problems that are going to come from this chapter are going to be very simple. So we will only concentrate on the types of problem that are going to come. Now, if we talk about drawing the free body diagrams, and we'll not spend so much time there. Let us draw the free body diagram of one or two bodies. So just to understand the significance of a free body diagram. Let us say this is a surface and I have two bodies M1 and M2 attached with a string, and then let us say I apply a force F on this block, and someone asks us to draw the free body diagram of the blocks M1 and M2. What all things are you going to draw here? I'll give you 1 minute to draw this one, and similarly draw this one. This is at an angle theta. Draw the same diagram but inclined at an angle theta. This is M1, this is M2, and this is F. Can you draw the free body diagrams in both the cases of block M1 and M2? I'll give you 2 minutes to do that. Are you done, bacha? Boys? Let me know if you're done. Then I will move ahead. I think you are done. Remember, the sort of questions that you are going to get would be pretty straightforward. You may not have to do all these things, but this is just for your theoretical reasoning that you should know how to draw a free body diagram. So what are the forces? Remember, you have to draw all the forces. So what you do, first of all, I just isolate these two bodies. So this is body M1. I put it here, and this is body M2. I put it here. I draw the forces on M1. First one is the weight M1G. Do we understand this? Then we have a normal reaction coming from ground. I will call it N1. Now remember, M1 and M2 are attached by a string. So this string will try to pull it. Yes or no? So let me call that tension as T. Why I have drawn T like this? Because it is going to pull. Strings cannot push. String can only pull. Okay. M2, weight is M2G, normal reaction is N2, the force F is here. Now remember, the string between M1 and M2 is going to pull. M1 is pulled in the forward direction and M2 will be pulled in the reverse direction. Do we understand this? So this is the free body diagram of M1 and M2. We all understand this? Now let me draw the free body diagram of M1 and M2 in the next case. I will not isolate them. I will just draw them. I hope you understand. The first one will be the weight M1G. Do we understand this? Downwards. Then there will be a normal reaction N1 coming perpendicular. Yes or no? Then again there is a tension T in the string. It will try to pull it upwards. This entire thing becomes the free body diagram of M1. We get this? Yes or no? How do you get the free body diagram of M2? We draw the force M2G, weight downwards, normal reaction N upwards, perpendicular, force F is already there. Then there would be a tension T which will try to pull it. This green thing becomes the free body diagram of the block M2. We understand this? Yes or no? Everyone?
Yes, sir.
Okay, I'll give you two more small examples because these are the questions that are going to come. So I'll only give you examples of those questions that you are supposed to encounter. So I'll give you three more free body diagrams. Number one is this. And I will ask you to draw the three free body diagrams of these three. Number two is this. Number three is this. So I've given you three free body diagrams. And I'll give you 2 minutes to draw their free body diagrams. When you are done, please let me know. Yes, bacha. Everyone got this? Shall I draw it? You need more time? You have done. Done, bacha. Shall I do it now? Okay. Let's do it. How are we supposed to do it? So I'll do it. I'll do all in one. I hope you will be able to understand. Let us first move on to M1. The first force is M1G. Do we understand this? Then the next force is normal reaction coming from ground, N1. There is only one string, so tension is T here. This is the free body diagram of block 1. Everyone got this? Let us see the free body diagram of block 2, M2G. It is in not contact with any surface, so only there one force, tension T, and this is the free body diagram of this. Yes or no? Okay, let us look at this one. This is M1G and this is T. There is no other force, no other contact, so this is the free body diagram of this one. Yes or no? Let us look at the other block. M2G, T, there is nothing else, so this is the free body diagram of this one. Everyone understood what I am saying, bacha?
Yes, sir.
Okay, let us draw the free body diagram here now. This is M2G and there are two strings that you see here. Yes or no? Do you see two strings? So let me call this string as string number 1 and let me call this string as string number 2. You see those strings, therefore there are two tensions. This tension is T2 because I've called the string 2, so I've called it T2. You can also call it T1, you can also call it T, you can call it X, you can call it Y, it doesn't matter. This is the free body diagram of this block. We got this? Now look at the free body diagram of M1. There is this force M1G here. There is also this tension T1 here. No, this is not T1. This is the same tension on the string T2 here. And then there is a tension in this string T1 here. So this becomes the free body diagram of block M1. I will draw it here if you don't understand this. This is block M1. One force is T1, the tension in one string. The other force is M1G and the upward force is T2. Do we understand this? Why there are two tensions? Because there are two strings. Let us move ahead with this M3. I will draw this M3 here also because, no, let me draw it there only. M3. Oops, what have I done? M3. So there is weight M3G and then there is only tension T1. So this blue thing becomes the free body diagram of M3. I can also draw it here for your better understanding. M3. The only force downwards is the weight M3G. The only force upwards is the tension T. Everyone has understood how to draw free body diagrams? Okay, that is great. Now, since we have understood what we have about free body diagrams, we have understood sort of what do you mean by a force. We have seen the types of force. Here, let me introduce you one more concept which I normally do not introduce at times here, but now I think for you, I think I should be changing the way I have been doing things. And then I will be starting with this one, and we will be writing the next thing that is known as linear momentum. So let me put The concept of momentum here only. Linear momentum. Linear momentum. Have you heard this term, linear momentum or momentum? Yes or no? This is normally written by the letter P. What is linear momentum? Can anyone tell me? What is linear momentum? It is a product of. Can you complete the sentence? Product of.
Mass into velocity.
Product of mass and velocity. Well done. It is the product of mass and velocity. So the formula of momentum becomes m into v. What type of quantity is momentum or linear momentum?
Vector quantity.
It is a vector quantity. Well done. What is the direction of this vector? In which direction is the momentum of a particle? It is same as the direction of. The direction of momentum is same as the direction of velocity, isn't it? This is v vector. This is p vector. P vector is m times v vector. Therefore, the direction of linear momentum is same as the direction of velocity. Yes or no? No or yes? Do we
Yes,
understand?
sir.
Okay. You can also call this linear momentum as the quantity of motion in a body. How much motion the body has. So you can very clearly say that there's a quantity of motion in a body. If you have a truck, big truck, but moving with a very small velocity, but because of a big mass, it has a lot of momentum. It has a lot of motion. And if that big truck hits you, it will do or hits a brick, it will do damage. Yes or no? Similarly, a small bullet. Maybe the mass is very small, but the velocity is very high. So the momentum is high. And therefore, that small bullet can do a lot of damage. Do we understand this? Yes or no? Huh?
Yes, sir.
Okay. Now, I have seen a lot of questions coming on this momentum based on graphs and all that. These are very simple points. And I will ask you to note them down point wise and just remember them and draw their graphs. So I'll just go about them. For example, if two bodies of different mass, they have the same momentum. These are all questions taken from exams. Momentum is same, masses are different. So the ratio of their velocities, and they have asked it many times, is an inverse ratio of mass. That means the body which has more velocity will have less momentum. Do we understand this, bacha? Yes or no? No or yes? They've asked this
Yes,
question
sir.
many times. They've also sometimes asked this graph. They have given you this graph. They will give you 5 graphs. And they will ask you which is the correct graph. So this is the graph between V and M when the momentum of the body is constant and the graph looks like this. So I would request you to draw this, write this, and understand this. If you don't understand this, please let me know. Do you understand the shape of the curve? When velocity increases, mass decreases because momentum is same. So body which has more mass will have less velocity. The body which has less mass will have more velocity. Bullet, less mass, more velocity. Truck, more mass, less velocity. Do we understand this? If they have the same momentum. Do we understand this? Yes or no? 2 minutes you have to draw this. Let me know once you are done, bacha.
Completed, sir.
Everyone has noted this down?
Yes, sir.
Okay, then we move on to the next thing. And again, I will show you two graphs based on the same concept. The first graph looks like this. And I hope you understand the meaning of this graph. For a given body, the body is given, that means the mass of the body is constant. Yes or no? So P momentum is M into V, my dear friends. I am not visible. Now I am visible. Momentum is M into V. If mass of the body is same body, momentum is directly proportional to velocity. So more velocity will have more momentum. This is point number 2. Do we understand this? The first one was point number 1. Are we getting this? Yes or no? No or yes? So it is getting above or it's saying bye bye. I'm going. Don't worry about me.
Yes, sir.
Well done. Then there is third graph. I've seen this graph in the exam, and that is why I'm doing this. So that once I do it, you will remember this. For different velocities, for different bodies, sorry, not velocities, for different bodies with same velocities. So as you can see here, velocity is kept constant. Momentum is directly proportional to their masses. Right? So basically this everything is coming from this equation, bacha. P is equal to mv. P is equal to mv. If you keep P as constant, M is proportional, V is proportional, inversely proportional to V. M is inversely proportional to V, or V is inversely proportional to M. If you keep M constant, P is directly proportional to V. If you keep V constant, P is directly proportional to M. Do we understand this, yes or no? Only one equation you have to understand, bacha, and the 3 diagraphs you can see. I'll give you 2 minutes to note them down.
Done, sir.
Everyone has noted this down?
Yes, sir.
Okay, now let us introduce the next concept here. And what is the next concept that we have to understand? The next concept that we have to understand, just give me a minute. Okay. So the next concept that we need to understand is the concept of inertia. Have you heard this term inertia? Have you heard this term inertia, bacha? Do you know this term inertia? Yes. Yes or no? No, yes. Hmm? Anyone heard this term inertia? It is a property of a body by virtue of which it resists. Yes, can anyone complete it now? It is a property of a body by virtue of which. Can you complete it now? Let me just put my. It's a property of a body by virtue of which it resists. Anyone? Any change? In the state of rest or motion. Have you heard this? Inertia. Yes or no? You have heard? If a body is at rest, it will remain at rest. If a body is in motion, it will continue its uniform motion. Have you heard this? Yes or no?
Yes, sir.
You have not heard about inertia? That is difficult to imagine. Anyways, you have heard it now. Do you understand it now? Will you remember it now? If you not read it, okay, no problem. Will you remember it now? Have you noted it down?
Yes, sir.
Okay. Please remember it now, at least. I hope you can remember it now. Okay.
Yes, sir.
So it is a property by virtue of which it will resist any change in its state of rest or motion. Remember, it is not a physical quantity. It's not a physical quantity. It's not a quantity that actually exists. It is not a physical quantity. I hope you understand. It is not a quantity that exists, but we still define it. Now, on what thing that this inertia depends on? This inertia depends on the mass of a body. Sometimes people call mass as the inertia of the body. Mass is not the inertia of the body, but mass gives us a way to understand the inertia of the body. If the body has more mass, we will say that body has more inertia. Do we understand this? Mass of the body tells us about its inertia or inertial property. Do we understand this?
Yes, sir.
So the inertia of a body actually depends on its mass. Inertia is different, mass is different. You can sometimes relate them, that whenever we think about inertia, we start thinking about the mass of the body. Do we understand this? They are not the same thing. Now, having said that and having understood this concept, everyone understood the concept of inertia? Then we can move on to the next concept. Everyone is there with me? Yes or no? No, yes. Have we noted it down, beta?
Yes, sir.
Then we can move on to the next thing, which is known as Newton's first law of motion. Anyone has heard about this law? Newton's first law of motion. Anyone has heard about this law? No one? Anyone heard about this law, beta? Newton's first law of motion in your 9th standard? No one has heard about it? Boys? No one knows about Newton's first law?
A body continues to be in rest or uniform motion until an external net force acts on it.
Who is speaking? I don't see anyone speaking, but I hear a voice. Okay. Got it. Yes, that is Newton's first law of motion. And it is exactly the way that you learned it in 9th standard. Nothing changes. A body at rest will continue at rest. A body in motion will continue its uniform motion unless disturbed by an external force. Do we understand this? So this is how you will write a body at rest remains at rest and a body in motion continues its uniform motion UM unless disturbed by or acted upon by an external force. This property is known as what is this property known as? This property is known as inertia. You just heard about this inertia. And the law is known as NFLM, Newton's first law of motion, or you can also call it law of inertia. If a body at rest, it will remain at rest. If a body is in motion, it will continue its uniform motion unless disturbed by an external force. This property of the body is known as inertia, and the law is known as Newton's first law of motion or law of inertia. I'll give you 2 minutes to note it down. I hope you will remember it now, bacha. Yes or no? No, yes? Huh? You remember it now? Arey, at least say yes.
Yes, sir.
You have to remember it. You can't forget things. So remember it. The more you can remember for NEET in physics, the better are you going to score. You know how much you need to score in physics to get a good college? Any idea? To get a really good college?
No, sir.
Out of 180, you'll have to score somewhere around 150 to get a really good college. 150 in physics, 150 in chemistry, that gets you to 300. Then 350 out of 316 bio will only get to 660. At 660, you might get a good college. So at least 150 you need from physics. So you'll have to remember a lot of things. Do we understand this, bacha? So please remember things. And the only problem that NEET students face, which I understand, is in physics. If you can remember simple things, then I'll try to give you everything possible. In short, you will do good. Have you noted it down, bacha?
Sir.
Okay. Newton's first law of motion or law of inertia. That means if force acting on the body is zero, so basically it says that, if I just write it in short, it says that if force acting on the body is zero, the velocity of the body is constant. Or in other words, the acceleration is zero. Do we understand this? It's as simple as that. Now, when you talk about this word inertia, and we have seen this word inertia, now this is very simple concept. We can have three types of inertias. One is known as inertia of rest, one is known as inertia of motion, and likewise, you can just note it down if you want to. So what do you mean by inertia of rest? Anyone? What do you understand by inertia of rest? What do you understand by inertia of rest? By inertia of rest, we will understand that if a body is at rest, it will remain at rest. Do we understand this? So that you can call, if you want to call it, as inertia of rest. It will not change its state of rest. It will keep on remaining in the same state of rest. You can call that property as inertia of rest. Then you can have a second type of inertia, and you can call that second type of inertia as inertia of motion. If a body is moving with a uniform velocity, it will continue to move in the same with the same velocity or same speed. Then you can also call one inertia as inertia of direction, which will resist change in any direction. Do we understand this? These are simple things. I mean, I don't think they are going to ask you this, but still, if someone asks you, this is how you go about it. Do we understand this? Why I'm telling you this? Because there have been questions that has come on this, and once you note them down, probably I can discuss those questions. One question at least. Have you noted this down, bacha? Have you noted it down, bacha?
No, sir.
Okay, do it first. I hope you understand the meaning of the terms. Inertia of rest means it will continue to remain at rest. Inertia of motion means it will continue its motion no matter what. Inertia of direction means it will not allow to change its direction. Shall I move on to the question? Okay, so this is the question that I was talking about. When a bus suddenly takes a turn, the passengers are thrown outwards. Why are they thrown outwards? Because of, and the correct option is?
Option A, sir.
Option yes, sir.
Option A, sir. We understand this concept?
Yes, sir.
So this is because of this inertia of motion that this thing happens. One more short question. If you can read it fast and give me the answer so that I can log this topic and move ahead. This is question number 2. Give me the answer fast. What is the answer for this one? A person sitting in an open car moving with constant velocity throws a ball vertically up. The ball will fall. Where? Okay. Think about it. Give me the answer in the next class because I have to move on to the next class. Okay. So think about it. Give me the answer in the next class. We are done with this. In the next class, we'll move on ahead.
Option D, sir.
Option D, sir. That is correct, sir. It will not go anywhere, but it will fall in the hands. Because if I throw it up, it also has a horizontal velocity. It will come in the hand. Just because the car is open does not mean that it will fall out. Okay. So I'll see you in the next class. Take care. Have a nice day. God bless you all. Bye bye.